So once again, welcome to the lecture number 8 of the deep learning course. In this session, we are going to talk about the neural networks, and our objective would be to find out that what is the importance of combining more than one neurons in layers. So let us start our discussion. So very interesting kind of discussion today we are going to have, because you know that a single perceptron till now actually this particular word is right now is a misnomer, because till now we have only studied about the perceptrons, and you know that what is a perceptron, and perceptron means that there is a unit in which various inputs are going, and there are associated weights with every link, and when the some value you are going to supply it, find out that weighted average of all those things and apply a threshold. So the unit that actually I am going to represent over here, it actually the represent the same thing over here. So when I am talking about the neural network in this particular slide, particularly everywhere there are only perceptrons, but you can equivalently think what is when the same thing is going to happen with respect to the neural networks, means the neurons also. What are the neuron? We have not till now we have not discussed, but in the today's class it would be clear to you that what is neuron and why it is very much important. So let us start by just having the assumption that we have some processing unit. So we have some processing unit. So here in this particular example, this I am going to say that I have three such processing units. I am going to call it as an input layer. What do I mean by this? Then means that I'm directly connecting something and taking the output. Okay. So when I say that it is an input layer, so sometime you may also think that okay, it is just an input thing. Okay. This is the first layer, and I'm going to have these things. And when I'm going to have three things and not going to have any kind of specialized structures, I can say that it is just taking the input and giving the same thing as an output. So it is the input layer. Then what I do, I put few more perceptrons over here. So few more perceptrons. How many perceptron? Right now you can see that 4 perceptron I have added. And very important property is this, that if you pick any of the perceptron, it is connected with the all the things which were there into the previous one. If you pick any one of them, it is connected with everything into the previous layer. So this particular kind of connection is called fully connected, or FC, fully connected kind of structure, where every perceptron that we have in a particular layer, it is connected to everything into the previous layer only. Okay, if there are any other layer over here, so generally we don't make these kind of connections. In the general settings, we don't make these kind of connections. But you say that this is the hidden layer number one. Okay, the first layer is the input layer. Why I am going to call it input layer? Because whenever I am going to provide x1, x2, and x3, they are directly being fed out over there, and we expect that the output is going to be the same. So that's why it is an input layer. So the first hidden layer, which actually is responsible for doing any kind of programming, any kind of computation, this is the first hidden layer. So weights would here every connection would have their individual weights. Okay, then we can put some more set of perceptrons, and we can call it the hidden layer number 2. And how many perceptrons here we have? 4 again. So it is not very much fixed that in this layer also you have to have the 4, here also you have to get the 4 things. It depends upon your requirement, and we are going to see that how these things are going to change. For example, let's assume here 4 things are there. Again, the same kind of architecture here also, that every perceptron is going to be connected with every other things in the fully connected way with the previous layer. As you have seen there, this was connected to everything. So here also it is connected to everything. Okay, every 1, 2, 3, 4, every other neuron into the previous layer. So this is the first hidden layer. This is the second hidden layer. Then we can keep on adding layers as we require, and at the end we are going to have a output layer. So in the output layer again we have the same kind of neurons. So it depends upon what is our requirement, and those many number of neurons we are going to put in this particular layer also. It is again going to be fully connected. So you see this kind of architecture. This kind of architecture is called the basic fully connected neural networks. Okay. All right. So into the output layer, whatever neurons are there, they are going to give you some output. Okay. And this output we are going to utilize for our classification or regression or whatever. For example, two things. If let's assume that we have three things uh, in our uh, in our classification problem. Let's assume that you are in this particular side, you are going to feed an image, and you want to understand what is there inside the image. If I say that that particular image, I have only two classification problem where I say that I have the image may have a cat or dog, then one perceptron is going to tell me about the whether it is cat or not, another is whether it is dog or not. So the output that I'm going to get, I can interpret as a probability, that what is the probability that it is going to be a dog, what is the probability it is going to be the cat. A lot of question would come to your mind that why I have put two layers only, why not 3, 4, 5, 6? Why I have put 4 over here, why not 5, why not 3? Why I have put same question over here, why 4? Why can I change this thing? Because of symmetry looks like that. If here I have 4, here also I need to have the 4. It is not like that. It may be possible here 3, here 5, here 7. All these things, all these combinations are possible. Why we take 3, why we take 5 would be clear to you in a very soon. However, all these things are called hyperparameter. Okay, and our task would be as a machine learning engineer, as a data scientist, our task would be to find out that how many layers are required. And let me tell you, this is not a direct thing, and it requires the domain knowledge, and then only you can do that. Okay, there is not no direct way to tell that what is the right thing over there. You have to have some kind of domain understanding to go ahead with these kind of things. As we have just discussed, number of layers may differ based on your requirements. Nodes in each what is this? Nodes in each intermediate layers may also differ, as I told you, sometime here 3, here 7, and whatever. Multiple output neurons are also used for the different classes. As we have seen that if dog and cat is only the two classes, we can have two. But if you want to do a digit classification, for example, MNS database, where now where the images have the digits 0, 1, 2, 3, 4, 9, any kind of digit is written on those numbers you want to classify, then with every kind of digit you have to put a neuron as an output. So with respect to 0, with respect to 1, with respect to 2, with respect to 3, all with respect to the 9. So 10 different perceptron you have to apply, and when you are feeding to the system, your system and the right parameter are actually obtained by your system, then the system would be telling that what is the probability that that particular digit is 1 or 2 or 3, and then obviously you would be picking that classification which has the highest value. This is a very important line. Next line is very important. That levels deep neural network, two layers deep neural network can represent any Boolean function. Can represent any Boolean function. Do you know what is the Boolean function? Boolean logic, you know that. The output is actually 0 and 1. You have seen that Boolean circuit. So let's assume that you have multiple variable. So into the Boolean logic, you may be aware that maybe the input is going to be A, B, C, and if you are not like you don't like, let me say that it is x1, x2, x3. So Boolean circuit could be, for example, if I say that 3, no, not the 3. It is x1 dot x2 plus x3 bar x1 plus x3 plus x2 x1 bar plus x3 x1. So these kind of circuits I can write. Okay, you know that I'm not going to mean anything specific over there, that what is the purpose of this, what is the minimum representation of this. Let's assume that this is a function. Okay, this is definitely a Boolean function. If I say that input is 0, 1, So it is going to be a Boolean function because it is also going to give you something like 0 and 1 only. Any problem in this? And this is a Boolean function. Any problem in that? So this is a Boolean function. So how many Boolean function you can create? Too many, means infinite number of Boolean function you can create. If you can come up with any app the Boolean function and ask with me that give me a neural network, I would always able to make that. This line says that I would always able to make a Boolean circuit for your problem. If I would always be able to provide you the neural network that would give the same thing. So any idea that how, on what basis I'm telling this? So let me give you the, let me give the answer. The answer is this, that you know that if there is a Boolean circuit, so you can represent it with the sum of product or product of sum. Soap and post form. Everybody knows this. Does anybody have a problem? Soap and post form. Sum of product and product of sum. POS is a product of sum. So into the post form, you say that into the soap form, it is a sum of product. So I say that there would be x1, x2, x3 plus x2, x1 bar plus x3 bar x2, like this. So there would be the individual terms would be multiplication. Multiplication means having and plus means or. So you can every circuit, whatever function you come up, okay, if you, whatever Boolean function you have, you can equivalently write it into this particular way. There is another representation, even you can change this thing to this, for example, x1 plus x2 bar dot x3 plus x1 bar plus something like that. Okay, you can also represent into this particular way, where things are actually inside, things are actually only individual term which are actually finding out which are actually and no, it's r, and outside there is a multiplication, means there is and. So both the things are equivalent, means what do I mean? I'm not going to into much detail. You know that from Boolean logic, if you have a Boolean function, for this but Boolean function you can equivalently write a soap and post form. Yes, can you write yes or no? Everybody, can you write yes or no? That if I have a Boolean function, I can definitely write soap and post form. So let me focus on any of them. So because they are equivalent, let me only focus for sum of products form. Okay. So what does it mean? That there are few terms. This is the first term, second term, third term. Okay. So for this, with respect to this particular term, I can say that with respect to this particular term, I am going to make a perceptron. With respect to this term, I can make a perceptron. With respect to this term, I can make a perceptron. How many terms are there? Whatever number of terms are there, for every term I am going to make a perceptron. You know that how to make and. In the previous class we have seen that if we appropriately select the weight, for example in that class we have set minus 20, 10, 10, like that, and using those kind of numbers I can definitely make this as an AND gate. So this particular term would be my output. And if I want to use multiple terms and for with respect to this particular place only, if you just consider on this thing, you forget about the previous thing. So here you are going to get this as a single term, and then you want to have an OR gate. We have also seen in the last class that there are specific weight values that if you adjust over here, then this particular next any particular perceptron into the next layer is going to act as a their um, their and their OR gate. So you can then combine all these things and you can get the output. Okay. So I have given the idea that if you have any function, you can convert it to the SOAP or pass form, and then for each of the literals which are there, you can build a perceptron over here, and then you can combine using, because here the AND circuit was needed, and in the next layer you need a OR circuit with the AND or OR circuits. Then you can combine and you can make the output of the same thing that which were given by this particular function. So in this kind of circuit, only two layers are enough. The first layer where you are having and next layer where you are going to R, and if you go for the pause thing, then R and you just only two layers are sufficient to give you any kind of output that you need. So let us try to understand this understanding with respect to a practical example. and this is the example that I have. So consider some of the data points over here which are actually shown to you. My question is whether this data is linearly separable. Please type yes or no. Whether this type is linearly separable. Please type yes or no. No. Why no? Because if I draw the line over here, if I draw a line over here, these things are correct, but these points are actually have a problem. If I draw a line like this, then this the below points are actually red. I think I have said wrong. Once again, if I say the line like this, then these points are correct, but these points are wrong because below side would be negative. So this becomes problem. If I draw a line like this, then these points are okay, but this point is wrong and these points are also wrong. I cannot draw any particular line in which all the points one side points are actually positive and the other side items are negative. I cannot draw any such line. Any idea that can we draw anything? Anybody? Can we draw? For example, if I draw a line like this, all the things become positive. So this is not the positive. Then we have a problem. I cannot draw a line outside. Okay. Inside, if I draw few things are correct, then because everywhere there are the things, then I would be into the problem. So there is an issue that this data is not linearly separable. Let's assume that we want to make a classifier for this. How to go ahead with this? Okay. So the idea is that I am going to not have the single line. Instead, I would be drawing three different lines. Okay. Now, if I divide the things into this, so three different line. Okay. One is the red line, one is the blue line, another is a black line. Three lines I have. Okay. This is the three line. So I am going to ask a question whether the red line is a correct line to do the classification. No, we have seen earlier because it has a error. Whether the blue line is correct? No. Whether the black line is correct? Answer is no. No one of these lines are actually correct. But then we can build a logic out of this. Okay. For example, we want to classify, we want to find out which particular point is actually, what is the condition when these points are actually green. Let me try to develop a understanding. And this understanding I am going to represent with respect to a table. I am going to make a table, and in this table I am going to say that that there is a red line, there is a blue line, there is a black line, and what is the color. And let's assume that the color I am going to talk about when I say 1 over here means what, that it is green. Okay, let us make this table. Help me to make this table. So I need your support. Okay, 0 0 0 means what? Let me tell you. Red line above the red line. Okay, so what is that area? This is the red line. This is the red line. Above the red line area means what? This is the area. Above the red line area means this is the area. Okay, this is the area. I am in this area. Understand? Above the red line. So is this clear to everybody? Above the red line. Am I okay? Can anybody write yes? Above the red line. Yes. Okay. Next is the blue line 0. Okay, I think what I did. Today I'm not into good mood. Looks like I'm doing so many mistakes. Okay, sorry for that. So let me, everybody, please interrupt me when I'm doing wrong. Okay, because you can also understand with me. Okay, red line 0 means I should be below the red line. Okay, so this is the area. Okay, I was wrong. This is the area. Am I right? So don't do the mistake like me. This is the area. Okay, I was talking about red line 0. Blue line 0 means what? I have to go below the blue line. Where is the blue line? Blue line is here. I have to go below, means this area. Am I right this time? So please interrupt me. So below this line means this particular area. Okay, I'm talking about this particular area. Everything is fine. So what do you think? I'm good in coloring? Hmm? I think your little sister would be doing better than me, na? No problem. I would learn one day. So this is the blue line. Next is the black line. Black line, I have to go below the black line. Okay. Let me change my color. I have to go below the black line. Where is the black line? This is the black line. I have to go below the black line. So I say that I am going to this particular area. Okay. So this is the area going below the black line. Am I right? So if I ask you that if all these conditions are specified, then what is the area that is there in which all these things are satisfied? All these things are satisfied. What is that particular area? Now it is an important part that all three, the area which is actually represented by 0 0 0 means what? It is below than the red line, below than the blue line, below than the black line. Okay, so I think this area, if I'm not wrong, is going to be this area only. Okay, I have done the, okay, so this is the area. Okay, so if I say that all three conditions are actually applied, so this is the area in which we are talking about. Okay, now let us focus on this particular area. So this particular area I'm going to talk about. In this particular area, what is there with respect to the items? Whether it is a green area or what area? Can you tell me whether it is a green area or red area? Whether it is a green area or red area? Can you tell me please? Green area. Yeah. So all the items are, you can see that all the items here, which are all the items which are here, they are actually green. So I say that color is equal to 1, means it is green. I'm talking about that whether the color is green or not, the answer is 1. Okay. Okay. So you understood that what I was meant by this. So let me do only one more example and proceed. The next example is 0 1 0 1. So below the red line means what? Below the red line, this area. Blue line, below the blue line means what? This area. Below the red line. But I think I should draw in that particular way so that it is not being violated. So I think it would be clear to you. So because if I draw anything over here, so there would not be any intersection. And next is a black line with respect to the above the black line. So if I go above the black line, what is the area? This is the area. Okay, only I am talking about this particular area. Means you understood that I am talking about this particular area. In this particular area, whether the color is green, no, it is the red area. So the answer here I write 0. Okay, here I write 0. So in this particular table, similarly you can create this particular table 0 1 0 becomes 1, and all other places it is going to be 1 only, because you know that this is the only area where it was red. So you very easily you can construct like this. Any problem with respect to this table? Any problem with respect to the table? Yes or no? Yes or no? Any problem? No, sir. Great. So I am going to make a neural network circuit that can do the classification of all my data points. These are the data points. I want to make a neural network circuit that can do the classification of all my data points. So what I would do, because it's a two-dimensional data x1 and x2, I have to feed x1 and x2. So I'm into the input layer. I'm going to put these two things. Everybody is okay with that? Any question in that? Next, what I want, that I want to have 3 lines. What are the 3 lines? Red line, blue line, and black line. So I have to make the logic for the 3 lines, and you know that I don't need to have any particular kind of thing if I want to make these things. So definitely the system would be able to come up with those parameters, because if these are the perceptron, they would definitely would be able to get the equation of that particular line. Let's assume that I said somehow I asked that give me this equation, give me the equation of this particular line. So perceptron would able to do that, because we have seen the perceptron is linear decision boundary. If I set my things in such a way so that it have to find out this line, it would be able to find out that line. Make sense? So I have created 3 lines. Okay, 3 lines. And then after that, when these 3 lines are there, I have to build this particular logic. And what is this logic? Can we see? Can we look closer? Can we look closer? So there is at only one place there is 0. All other places there is 1. So this looks like that it is a kind of AND kind of circuit. Okay. If I negate my output, so everywhere there would be 0, 1, 0, 0, 0, 0, 0. If I negate my output is going to be this. At one place there is 1. You know that how to find out the 1 at that particular place with respect to these values. So I put another layer where I put a neuron, and this is going to combine these things in such a in the AND way, and then I'm going to get the output that is going to be 0. Make sense? I want to make the output 0, otherwise 1. And then I also need another thing that can negate this thing. So 0 becomes 1, 1 becomes 0. So I have created the circuit for this at this particular place. Then I have done the negation to get the circuit from at this particular level. Make sense? So this is where I have combined this output, and then ultimately I got the output. So I have so any questions in this? Do you understand that it is fine if this circuit can find out the right parameter for my problem? Yes or no? In this example, why the HL1 becomes an OR gate. Hidden layer 1 is an OR gate. No, hidden layer 1, what I told you, that hidden layer 1, this particular layer, it is going to represent a line. There would be a line with respect to the red one, there would be a line with respect to blue one, there would be a line with respect to the black one. If you talk about here, okay, so if because you want this kind of output, na, you want this kind of output, okay, what if the something is 0, 0, 1, because this is going to give you 0 and 1. You understand? If the point is above the line, it is going to give you 1, otherwise it is going to give you 0. This part is clear to everybody? Who is asking? Mr. Das. So all these things are, it is going to give you 0, 1. So these outputs you are going to get. So at this particular place, you have to get the output of this particular kind. Make sense? That you want to get the output of this particular kind. And I am just only telling that you can see this into a different way. You can say that here it is 0, here it is 1, 0, 0, 0, 0, 0, 0. You can look into this particular way, then making the circuit would be easy. If there would be multiple places 1, then I need multiple neurons over here, and then I have to combine it. Okay. So luckily in this particular example, only one place there is 1. So I can find out the equivalent circuit for this particular input, that in what case if I find out some circuit, for example, if this is R, it is B and it is a small b, I say that R B B bar. I think I should say in this particular way, R bar B bar B. If this is the output of this particular perceptron, then I'm done. I will be getting the 1 at this particular place. Am I right? If this is the output of this thing, and can I make my question is, can I make a perceptron whose output is this? Answer is yes, because previous classes we have seen that we can make AND and OR gates with these inputs. We have seen that this can represent as an AND and OR gate. In the previous class we have seen this. I will not go into that detail right now. You can see the previous lectures. So if this is going to act as an AND or OR gate, right now what I need? AND gate. So I would be getting the output, but at this place I would be getting what output? 1, because R bar B bar small b, it is going to give you what? It is 1 at this particular place, and all other places it is going to give you 0. So again I get a NOT gate at this particular place, and you know that NOT gate is also possible. We have seen that. What are the right parameter to make a NOT gate? So got it, sir? Okay, good. So in this way, this is a circuit. My question is that this is a circuit that can give you the classification of this thing, provided the right parameters are there. Right now, you know that by your your own understanding, you know that what should be the right parameter. Now you can write it, because in the previous classes we have discussed that what should be the right parameter to find out all these things. So you can come up with we do a home calculation on your paper and find out that what are the right parameters that should be here, and you can put it here. But let's assume that I'm not going to put it, and I'm asking from the system that can you find out the right parameter that gives me the right classification all these particular data items. Let's assume that there exists some technique that can find out this. So definitely my question is right now is only this, that if I devise the circuit like this, then this particular right now my problem, which was the classification of the items over here, can be solved. So the Prabhav is asking that whether the fourth column is being represented by the output layer. As I am telling that this is the output. Okay, this is the output is being produced by this. We need a not over here. Okay, so this fourth is going to give you the output layer. Yes, it is output layer. Okay, Prabhav, clear? So now I want to tell you this, that given the problem, if you understand your problem into right way, what I'm telling, given the problem, if you understand your problem into the right way, that looks like that there are 3 or 4 lines are required, then you can build a circuit out of this, and this is the hyperparameter that you have to come up with, and this is your task. This is not the somebody else task. The computer automatically doing this is going to be difficult. If you can come up with this thing, your system would be able to find out the right parameter for you. If let's assume that some few red points were there, so you can think that looks like that I have to build a circuit for that particular part also, and then you have to develop a logic by how to combine them. Okay, at the top means that you have to need more layers. So the complex problems need more layers. Okay, till now it is clear. Hope you understand that what is the need of multiple layers and how they are going to build the things at the higher level. And I think from this slides itself we can talk about this understanding, that here we were only talking about the lines, but here we are not talking about the line, we are talking about the complex way of combining these lines and finding out some bigger structure out of that. And here we are actually final layer is going to build the final classification logic, that whether should we take the positive or negative and some kind of things over there. So when we go above to the layers, means what does it represents? It represents the higher level of the understanding and the concepts and orders. All right, any questions? Okay, so neural network is appropriate for the problems with the following characteristics. What is the characteristic? Instances are provided by many attribute value pairs, means lot of data is provided to us. If lot of data is provided to us, okay, the target function could be discrete valued, real values, or a vector of several real or discrete values attribute. That is possible because we have seen that at the output layer multiple neurons we can put. Training example may contain error. This is a very important thing. If your training example have error or noise, then it is better to go for the neural network. Okay, long training time is acceptable because it takes lot of iterations to find out the right parameter. So long training time, if you have long training time possible, then only you go for the neural network. They are not very fast. You, in terms of the learning, at the time of the learning you have to give time to them, but when they learn they can produce the output immediately. Fast evaluation is needed. For example, when you are going to make a self-driving car, so in that particular system, the cars need to react immediately when there is something happening on the road. But if it takes 10 days to train, that is fine. Okay, in front of the car if something comes, car need to give the response immediately. So this is the fast evaluation. If something happens, comes to your car, the time is going to be, time need to be quick, because you know that if there are multiple layers and there is some input, it is only going to take this much amount of time, in the amount of time that only needs for the values to flow from one place to another. At the end you get the what is the output. So you get the answer in very less time, However, training may take a lot of time, because if you want to build the system, it may take 10 days to train. So if you have a lot of time for the training, but you need the fast answers, then in those kind of scenarios, you can apply the neural network. A very important thing that is actually associated with the neural network is this, that when the parameter are get learned, okay, when the parameter are get learned, and you have the vectors over all the places there are vectors, and if you want to describe them, that what does they mean, so maybe you would not be able to describe them, because I mean, to the previous example that when we are talking about here, in our this example, so here only you can describe something. So we have actually developed this problem in such a way so that you can understand about the table and understand about the things which are actually here. But if I don't give you this particular logic and ask from your system to come up with, so maybe you would not be able to describe this into right way, okay, because human description is sometimes needed, but it is very difficult for you to interpret that what they mean. So interpretation is actually very difficult when you get the parameters. So human understanding, if the human understanding is not needed, then only you go for these kind of things. All right, till now what we have understood, that if you have a big problem, if you have a big problem, complex kind of problems where complex kind of things you want to do, so you can build a neural network, okay. So you can do a neural network. In the neural network, everywhere the basic, who are the basic components? Perceptron. Right now we have only perceptron are the basic components. We want to train them. We have seen some algorithm that how to find out the appropriate parameter for this into the previous class, and that was actually trying to use a gradient descent kind of method, and we got that perceptron training rule. We have seen into the previous class that there was something called perceptron training rule. Using the perceptron training rule, we were able to find out that what is the appropriate parameter. Recall that what was the scenario there. The scenario was there that one side there were positive item, and another side there were negative item, okay, and we actually wanted to find out the equation of the line. My perceptron was trying to find out that what is the equation of line that divides this linearly separable data in a right way. But what we have seen, that when we started initially, the error was on the 10 points, then we have updated the parameter, error becomes on the 8 points, updated the parameter, error becomes on the same points, 7 points, updated the parameter, error again becomes on the 8 points, updated the parameter, error becomes the 9 points, updated the parameter, error becomes on the 5 points, at the end error becomes on the 0 point. But this fluctuation was a very problematic thing. Sometime there was an error on the 8 point, then there was a error on the 7 point, then again it goes to the 9 point. Why it was happening? Because with every update the line is going to change, and therefore the number of points are the points which are going to be classified as going to be different, and that's why we were actually having these kind of issues. So there is a specific issue, but with these kind of learning methods, and the issue is this. The first issue, that we started with the assumption that data is linearly separable, but actually this is not the case. Most of the time data is not linearly separable. So when this assumption is not there, that data is not linearly separable, what is the problem? That at the end, when we it is not going to be 0. At the end the error is not going to be 0. So the biggest problem with the non-linearly separable data is this, that we cannot go to the scenario where the error is ultimately going to be the 0. Okay, so let me give you the situation. Let's assume that in this particular setting, only, so let's assume that we have these values: initially 10 point error, then 9 point error, then 7 point, then 5 point, then 7 point, then 11 point, then 8 point, then 6 point, then 3 point, then 8 point. Anything can happen, okay. So when I was doing the iterations, and I got that my error is at the 5 points only, should I stop at this particular point? or should I go ahead and into the hunt up something? For example, there is some point where the error is only at the 3 point, and at the 3 point itself I have a confusion that whether I should stop at this particular point or go ahead at the end, because I know that 0 I'm not going to hit. So what is the minimum number that I would be able to achieve is not clear to me when I'm going to start my thing, start my parameter discovery. So I would be into the very bad shape here, that when I actually am going to do the parameter discovery, I don't know that where to stop. And if I don't know that where to stop, actually, then very difficult for me that how much training is needed, what is the optimal parameter. So it is very difficult to find out that. When data is not linearly separable, error fluctuate with the parameters when we do the training. So it is difficult to decide when to stop. So this is a big problem. And generally, you know that the data is not linearly separable. In general setting, the data is not linearly separable. So what to do? So if we till now we have discussed all the lot of things, but all those things would only work if my data is linearly separable. If my data is not linearly separable, then definitely the setting in which till now that we have till now studied would not is not going to work. There is again a question, sir, is this because the feature engineering part is automated here? So it seems like a black box problem. Actually, I'm not able to understand for which you are talking about. You can speak, no problem. Sir, this is because the feature engineering. What is the problem you are talking about? There is a message by Prabhu. He is asking that, sir, I am asking about the unexpected error. What is unexpected error? I'm also not able to understand. So my setting is this, that my data is not linearly separable, means plus items are there, and zero items are, most of the zero items are there, but inside the plus there are plus items. Okay, now I cannot draw a line. Okay, how we cannot estimate these fluctuations? Okay, we cannot estimate this fluctuation because we cannot understand this fluctuation, because sometime the line would be here, then the line would be here. It would be dependent upon what, that who are actually misclassified. It depends upon the points, it depends upon the data points. So with respect to the technique, we cannot tell that how many points we are going to do the error. Initially, if the parameter is this, let's assume the initial parameter is this, we have 10 points where there is a problem. Then my algorithm, perceptron training rule that we have seen earlier, is going to modify this parameter to this particular value, for example. Now the number of error would, because it is going to make the things correct, maybe we are going to get the error on 7 point. We cannot a priori tell that this is going to reduce how good this particular thing is going to do, because those points may be correct and some other points may have the problem. This is the point I wanted to make, that when I'm going to update this parameter from here to here, then I'm not sure that whether this is going to reduce the error or going to increase, because to see that I have to again go to the database, see for all the data, and then only I would be able to find out whether it is going to do better on the overall data or not. And again, if even if we know that it is going to be better, but then I want to again reduce this, it may next time becomes 8 point error. Understand? In the next iteration, when the line becomes this, I would be getting the error on 8 point. It is also possible. We have seen into that particular class, into the first perceptron class. So it is very difficult for me to understand that whether should we stop at this particular 7 point, or we continue, maybe at the later point of time we can get the error on 3 points. We don't know here. Prabhu? Here we don't know that whether after some time there would be error on the 3 points only. It also depends upon the initial setting by which we start. So that's why it is very difficult for me to initially tell that where I would stop. All right. Once again, one caveat in this particular understanding is this, that using the perceptron training rule that we have seen earlier, I'm talking about. I'm talking this with respect to the perceptron training rule that we have seen earlier. Okay. So what is the way around this? How can we solve this particular problem? Okay, so to solve this problem, another algorithm comes, that is a delta rule. That is talking about the delta rule. What is the delta rule? You know that. What is the perceptron, that you are going to be given some x, there are some weight, and then it find out the summation and then applies a thresholding. So you are going to apply a thresholding on W transpose X. Am I right? So by this you are going to get what value? 0 or 1 value. You are, by this you are going to get what? 0 or 1. By this you are going to get 0 or 1. So a very small kind of change that I am going to do. I am going to say that in this particular equation, when I was writing that W transpose X, and then I am going to apply a thresholding on this, I am telling that remove this thresholding part. Remove this thresholding part. Okay, because due to thresholding, values are going to fluctuate too much. Okay, this fluctuation I am going to reduce by reducing this kind of thresholding. What do I mean by this? Okay, so let me tell you. You know that the effect of thresholding is this, that let's assume that the values are 0 and 1, and if you have 0.6, 0.6 becomes 1. If you have 0. Let me draw the line like this. This is the 1, this is the 0. And let me also say that there is a line at the 0.5 threshold line, 0.5. If a point is here, you take it at this particular place. If 1, if the point is here, you take it to the 0. If the point is here, you take it to the 0. If point is here, you take it to the 0. Okay. So this is the task of the thresholding, that it sees that it introduces lot of things which are actually not there. Okay, this particular portion it is going to fill by itself. What I am going to tell next is this, that instead of using the actual output that you get after the thresholding, you use this particular value only. In this particular kind of setting, if I want the output should be 1, then this value cannot be now. Earlier this value was what was this value? Earlier this, even if this value was 0.6, it was okay for me. Okay, for the classification it was okay for me. If the value was 0.6, it was okay because threshold make it 1 and I'm done. But if I say that no, I'm going to remove this thresholding part, if I say that I'm going to remove the thresholding part, what does it mean? That no, this time this value should be very near to the 1. This is not accepted value. If it should be right classification, maybe this value should be 0.9. So my method should pick this value in such a way so that this become higher value. If for example if it is 0.3, no, it is not going to work. I need 0.1. So it should be very near to this, and actually I need 0 or I need 1. So if I remove this thresholding part and I say that my output is going to be determined by W transpose X only, then what is going to happen? That my parameter are set in such a way so that the value of W transpose X is not going to be very far. Earlier it may be possible, into the previous one it was possible that the value was very far away from the 1, but even then we were telling that it is we were taking it as a classification thing. So in these kind of settings, when actually I am going to say that I am going to use this value for the classification, how can we say that what is the error? Earlier how we were telling that what was the error? We were trying to find out that what is the target minus output. If it was a different value, we are going to see. So same thing we are here also going to say, that if the target minus output I am going to use uh, as a difference, and this value I want to minimize. Okay, so if into the earlier setting, if the value was 0.6 and thresholding make it 0. Thresholding made it 1, and I wanted the output to be 1, the difference becomes 0 and I got the 0. I am very good. But in this particular new setting, if the value is 0.6, I wanted 1, the difference is 1 minus 0.6, that is 0.4. So this is a big number with respect to the 0. So I am going to change the setting. I am going to tell that instead of using the perceptron training rule, I am going to use a different training rule. In this particular rule, I am removing the threshold value from the perceptrons, and the error is computed with respect to what was the target expected and what is the output that I am going to get, and the difference between those two things I take the square so that negative become positive, and find out the summation on all the data items that we have. I put a half over here just for the mathematical convenience, that would be clear to you. So if I am going to define the error in this particular way, make sense? Okay, if the error is this is the right error, na? Everybody understand that? Okay, if the points are misclassified, this value would be higher. There is a question, sir, is the threshold line working like a activation function for activation of a neuron? So definitely it is activation function, because thresholding is a activation, na? It is going to change the things. Okay, if there's something greater than this, then you make it 1, less than this you make it 0. So threshold line is a activation function, yes. All right, so very important thing is this, that if we want to find out the right parameter, for example, if the w is, for example, w0, w1, w2, dot 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 wn, okay, n parameters you have, and you want to find out that what is the right value, for example, what is the right value of w2. So we have seen earlier also that we can go ahead with the gradient descent kind of method. Means if we do a small change, w2 is equal to w2 plus something delta. If we do a small change into this particular w, we want to see that what is the effect of this particular change on the error. What is the effect of this particular change on the error? So if we can find out what is del upon del w2 with of this particular error quantity, when I'm going to change something, so you can utilize this thing, because if it is positive means what? If it is positive means what? That by adding this thing, your error is increasing. Then it would be nice that if you can subtract that particular quantity. Okay, we have seen this earlier also, that this kind of mechanism we use to optimize the parameter. So we find out the derivative, and we go into the opposite direction of this derivative. If it is positive, we subtract. If it is negative, then we increase. So because we ultimately want to reduce the error. So the to find out the right parameter, what is needed? Everybody understand this now, that we have to find out that what is the derivative of this particular quantity with respect to the any wi. Let us try to understand that what is the derivative. I think you all are better than me in doing all these mathematical computation. Let me just quickly seek your approval. So let's assume that I wanted to find out what is the derivative of this particular quantity with respect to any particular weight, say wi. So I say that del upon del wi. If I want to find out this particular quantity, help me to find out del up of e w with respect to del wi with respect to any particular I. What is the value? So you know that here half is there. So half is a constant. There is no problem. You go inside, it is term by term. Many terms are there. So you can see that all these terms are written one by one. So uh, since there is a square term over here, so you can again put that because individual if there are multiple terms and there is a summation, so if you find out want to find out the derivative, so it is going to be the derivative of individual term. So I can put the summation without loss of generality, half of w. Let me take this half from here. I can go inside and find out what is the derivative with respect to this quantity. You know that derivative would be 2 multiplied by td minus od. For this for respect to this data item, uh, what is the target, what is the output, td minus od, and then the derivative of this particular part, derivative on del wi of td minus od. Am I right? This is the, am I writing correct, everybody? Okay, this is what the value is. So this particular thing, you know that there is half and 2, they can get cancelled. So from here what I get this thing, td minus od. Am I right? Summation term is there, and then inside I have to find out this. So let me take it out, because um, let me take it out and just see this summation term inside. So it is a summation of all these things, and I want to find out the derivative. Okay. What is the TD? TD is a constant. Okay. What is the output? Output is being computed by my equation. What is the output? Is equal to W0 x0 plus W1 x1 plus W2 x2 dot 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 plus Wi xi plus dot 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 Wn xn. This is what we have. Okay. So if you want to find out the derivative with respect to the Wi, so you can see that only one place there is Wi and no other place there is any Wi. So you know that derivative actually cancels this all these parts, only this part would survive. And what is the derivative of this particular thing? Because only one variable is there, so output would be xi. Am I right? So the output on of TD is going to be so can I write like this, that inside I what I did once again, let me say this, that I have taken this part out, and 2 and 2 got cancelled, so I got TD minus OD, and then inside there was a long summation chain. In this summation chain, okay, only xi is going to be survive and all other things are going to die. So here inside what I get only this particular term is going to be 0 minus of what? Xi. 0 minus xi. All right. So it is TD minus OD, and this minus this 0 goes away, so minus of xi comes out to me. So if you want to find out the right parameter, you have to use this particular quantity, and you have to add eta time of that particular quantity, to the value of Wi. So Wi is equal to Wi minus eta time this quantity that we have just computed. That derivative of this eta term with respect to Wi is what? TD minus OD and XID. For all the data items that we have, you have to find out this value and you have to add this thing to your W. Make sense? Okay, so I think we are going out of the time. So I just wanted to, we can take this into the next class, that using this kind of using this kind of update strategy with each of the data item, I am going to do this multiple number of time. Okay, I'm going to change it with the multiple number of time. Only small change. What is the change? That instead I have removed this uh, thresholding part from here, and I have updated this with new equation. And using this kind of new equation, what is going to happen, that my error is every time going to reduce. Okay, it is not going to increase and decrease, it is every time going to reduce. So what would happen, that initially the error would reduce with much higher, but after that sometime less error would the E would reduce with the lesser strength. So we can find out what is the, maybe at this time when I was going to with the higher gradient, here the less gradient is there, we can find out there is a point called elbow point. We can stop at this particular place and say that now we have the right kind of parameter. So with using this kind of strategy, we have what? My error is continuously decreasing. So we would come back to this particular slide once again into next class. So that's all for today.